So this is problem number 7. The directions ask me to solve for the roots, the zeros, x-intercepts, all of those using quadratic formula. So I know I need to get this in standard form so I can label A, B, and C and plug it in. So first things first, I have 12x squared minus 3x. I don't have a c here, and that's equal to -4, which means I need to get rid of that -4 by adding 4 on both sides. Since there's no x, it's alike with that 0. So standard form would be 12x squared minus 3x plus 4 equals 0. Now I can label A, B, and C. A equals 12, B equals -3, C equals 4. Here's my quadratic formula that I'm going to be plugging those into. All right, so I'm going to take opposite B. It was negative, but I need to do the opposite of that. I'm going to make it +3 plus or minus square root of B squared. So that's going to be -3 squared. Notice when I plug in, I'm going to put in parentheses, minus 4 times A. A here is 12 times C, which is our 4. All over 2 times A, and our A was +12. All right, so I need to simplify underneath the radical. All right, so in my calculator, I'm going to simplify what's under the radical first. I did -3 squared minus 4 times 12 times 4, and that gives me the square root of -183. All right, so I have 3 plus or minus square root of -183. And then 2 times 12 gives me a +24 here. Now, right out the gate, when I have a negative underneath the radical, I know no number times itself will ever give me a negative, so I know I'm dealing with imaginary numbers. To get rid of that negative there, I'm going to take out an I. So I have 3 plus or minus I, and now the square root of +183 over 24. Now I want to ask myself, can I break down 183? So I can do this 2 ways. I can go ahead and change it to a decimal, or I can break it down doing the factor tree. All right, so I'm going to take the square root of 183 in my calculator. That gave me 13.53. So I'm going to have 3 plus or minus 13.53i all over 24. Now, 3 and 24 they have common factors, but 13 does not, so I can't simplify any farther. The important thing here is that we have I, so this is 0 real roots. Technically, we would have two complex roots here.